We'll be starting the session in just 5 minutes.
Yes, yes.
Good afternoon, sir.
Good afternoon.
So, this is our last session. So, we'll be taking on parametric and non-parametric test. So, and he has already taken the session in the beginning of which was the first session. So, I would like to just ask Dhaval sir to please start the session. Thank you so much.
Thank you. Am I audible? Hello. Hello. Am I audible? Hello. 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 Jugal sir, am I audible? Hello.
Yes, sir.
Okay. Okay. I'll start with thing. Is my word file visible to all of you?
Yes, sir. It's visible.
See, when you collect after collecting the data, you have understood by many resource person have must have talked about that what is a big data. Basically, all the data in any format, which is like a audio file, video file, image file, the collection of all this is known as the big data. Now, when you collect this data, it is having some problems. It suffers from some problems. And can anybody tell me that what are those problems which can be there in this data? Anybody? What can be the problems in this? Anybody who is listening? Hello, listening? What can be the problems? Rahul Suthar, Dubey Prashant, Sanjay Patel. So the problems can be that the data is having missing values. It can be having a problem of duplicates.
More outliers.
But where are the participants? Where are the participants? Duplicates and outliers. Now we have to rectify this by using some methods. Okay, those methods are dependent on which program you are using it. If you are using a missing values, then if you are using SPSS commands are very simple. It will directly go there and it will rectify and the things will be simple. And in R, you will have to write down the command for missing values and duplicates and for identification of outliers. Once this is done, then you will have to establish the normality test. You will have to run the normality test in the variables. Okay. It means that if the normality means that you are trying to check that is your data normally distributed or not. Okay, is your data normally distributed or not? If it's so, it means that your sample is a true representative of the population. If your data is normally distributed. In case if it is not distributed, then what are the procedures and what are the remedies? In case if it is not normally distributed, then what to do? So the first thing which can be done is increase the sample size. I will come to parametric and non-parametric test, but this is we have to channelize the thought process in this manner. So increase the sample size, remove the outliers, remove the outliers, and you can do transformation on the data and log transformation on the data. If normally is established, we run parametric test, and if it is not established, if it is not established, then we go for non-parametric. Now, whenever you run this test, first question arises is, what is my hypothesis? Okay, hypothesis. Or rather, it is also known as researcher's hunch, which means that it talks about the curiosity of the researcher, which means that suppose everybody was interested in last year, everybody was interested in that how this corona is spreading. Okay, how this corona is spreading. There was a curiosity. The second curiosity is who is most infected. Right. When will the pandemic end? Such questions are talking about the curiosity of the researcher. Now, in this, the researcher has to frame the hypothesis. And in this hypothesis, we come across null and alternative. Null talks, null is the information which is considered to be empty and void, which means that there is no association, relation, difference between the variables. Alternative can be there is a association, relation, dash, dash, dash. Everything is present. Now, to establish this, we cannot say that it is a judgmental view, and from the numbers, I will check and tell you that the relationship is there or not. You cannot accept any hypothesis unless and until it is having any empirical evidence. This will be picked up by a researcher. So, researcher collects the sample, and when he does this empirical testing, it is known as empirical evidence. So, the burden of the proof of giving any theory is onset given to is given to the researcher. So, if he or she wants to prove anything, that I want to prove that this relationship exists, see, a person has to collect the data. Now, this data can be in different levels of measurement. It can be it can be nominal, just a minute, all of you. It can be nominal, ordinal, and interval and ratio. The example of nominal can be the example of nominal is gender, male, female. Ordinal can be rank. Interval can be the temperature, and the ratio can be weight. In one person, we can have all these three levels of measurement. A gender, our gender is a nominal. What rank we get in any class or in any situation is a ordinal. Our body temperature is interval, and our weight is ratio. Now, why this interval? What is it? What is the logic of this? Is why it is interval? Because here 0 is not a true zero. It means that if I'm writing 0 degrees Celsius, okay, if I'm writing like 0, 0 degree Celsius, it does not mean that this is a absence of temperature. Absence of temperature means 0 means 0. We cannot say here, or in the night when you observe your clock and if it is showing the time 00.00, you will not tell that there is no time. You will not tell that there is no time. Time is there. So in case of interval, 0 is not a true 0. But in case of weight, which is in ratio scale, 0 is a true 0, means if you say 0, it is an absence of phenomena. 0 weight means there is no weight. Now the software does not differentiate between interval and ratio scale. The software does not differentiate between interval and ratio scale. For any software, interval and ratio is collectively known as scale variable. Now, when this scale variable is there, okay, so a scale can measure meter, right? Our normal traditional scale can measure meter. So it is known as metric, right? As if you can measure any variable on a continuous scale like age, weight, which is on metric scale, you can also compute its mean and standard deviation. If you can compute this also, it means that you are in the position to estimate parameter. Okay, it is known as parameter, and therefore collectively metric and parameter is known as parametric. Right? Now comes the second part: nominal, ordinal. If I borrow first letters of both of them, it will be N O. So this is no. So here I cannot apply parametric test. I will apply non-parametric test. Right? Okay. Now the parametric tests are which we can apply are parametric test which we can apply are T test, ANOVA, Mankova, sorry, ANOVA, MANOVA, Mankova. All such types of test can be conducted. If your data is not normally distributed, which is a basic assumption of using parametric, you should be meeting this assumption of data normally distributed. If your data is not normally distributed, you use non-parametric test, which is equivalence of parametric test like Mann-Whitney U test and Kruskal-Wallis test. treatment test. Okay. So there is a whole concept of hypothesis, sorry, objective linked with hypothesis, linked with desired test, hypothesis, then collection of the data, then to check normal distribution, and if you get the normality, then you use PT, and if not, then NPT, right? To reject null or to fail to reject null, now it is a high time that we will try to explain that what is the statistics which we will consider. Anybody having any opinion about this? Heard about it? Anybody having any opinion about this? Okay. So here, objective, hypothesis, data normally distributed. Okay. Suppose if I say that I am having a research hypothesis that consumption of coffee increases the blood pressure. The alternative will be alternative. Sorry. Now the statistical hypothesis will become there is no effect of consumption of coffee on the blood pressure. This is null. And alternative will be there is significant effect of consumption of coffee on blood pressure. Now, when will I accept, or rather, we reject or we fail to reject the null hypothesis? Okay. So that we will have to understand. And under which scenario we reject or we fail to reject null hypothesis. So for this purpose, there is something which is known as the p-value is less than 0.05, we reject null hypothesis, and if it is more than 0.05, we fail to reject null. Okay. So with this normal understanding, let us do the hypothesis testing in SPSS.
और है नहीं नाश्ता करवा नहीं और कंप्यूटर में
Okay. I will open the data set which is employee data. Now here I have collected the data. First of all, whenever you get any data, you will have to see its level of measurement. So this is in scale, right? ID is a scale. Normally we say that we cannot take it in scale because ID is just a number and we never analyze anything in ID. Now pay attention here how to analyze any data. Okay, pay attention here. Variable view is a gender, categorical variable, birth date is again scale, but I cannot use it for my analysis because such type of data cannot be analyzed. Education, I will consider it as a categorical variable, though it is written as ordinal. Job category is again a categorical variable. It is its salary is continuous, salary begin is continuous. Okay. Now, what we can do if we are having, if we want to do the univariate analysis in such things, okay, univariate, then what will be my, what type of statistics will I generate in univariate? So just see here that if your data is, yeah, if your data is non-metric and if your data is metric, that includes the scale variable, and here it includes the nominal and ordinal variable. So just see the data file and try to segregate that which falls in this category. So gender, job category, and education falls in categorical variable. So what I can compute of this, I'll directly go here, analyze descriptive statistics. I'll definitely talk about hypothesis testing, but first of all, we will have to go from the basics and from there we will have to pick up. So when I talk about the categorical variable, the first line is kept reserved for the categorical. So I'll click on it, frequency, and I'll say that please tell me the frequencies of gender, education level, employment category. Statistics I want is I cannot have a mean of the categorical variable and I'll not tick that. I can go for charts, bar charts, continue, format, organize output of variables, continue. Click OK. So this is what you get in a categorical variable. Okay, bar chart. Now here we are not getting any percentage, so I'll double click on it. And when I include the percentage here, it will give me the percentages. Close. See this? It is giving me the values, but if I go there and change it, it will also give me the percentage. Now I can also have the combination of two categorical variables that we will see later on. This is a concept of education level. This is a concept of employment category. So what the thing is, you have to see only in this cell, non-metric, and you can compute the bar chart and mode, or at the max you can compute median. Nothing more than that. Now, if your data is in ratio or interval, you can go for histogram and computing the mean. So I'll go here and I'll take analyze. Oh, sorry, from graphs I will go here and I'll pick up the histogram and salary. Click OK and you will get the histogram. See that how many of them are in this range. Okay, how many of them are there in this range? So if I want to see the frequency polygon of this, double click and I'll get the frequency polygon. It will tell me that your data is not normally distributed, and in no circumstances you can use parametric test. You will have to go for non-parametric because there is a high skewness in your data. Why? Because there is no data here in the white portion. So a univariate analysis, you can either plot scatter plot or bar plots or pie chart. Okay, and the statistics which can be computed is a count. So what is another type of thing which you can do? Go in descriptives, go here and frequency, generated frequency, generate the statistics which are related to it, and it will give you the statistics related to it. That how many, what is the education level, employment category. Just a minute. Okay, now let us go back and try to understand that what to do in case if we are having two variables running together. Okay, one more thing which I forgot to tell you is that for nominal you can only compute mode, for ordinal you can compute mode and median, for scale you can compute mode, median and mean. Okay, now the next level, what to do if it is we are having non-metric and non-metric, two variables together, what you can do, non-metric and non-metric. So in that scenario, what we'll do, we'll go here, two categorical variables are there. We can go from two ways, analyze, descriptive statistics and cross tabs. And now here, what you can do is I can include the gender into row and for example, minority here. Display clustered bar chart, right? Click OK and you will get the clustered bar chart. See what it is telling me that it is non-metric to non-metric clustered bar chart can be computed. Clustered bar chart can be computed. Now, if you are having two continuous variables like this, that is the current salary and the beginning salary. So from here, you can go in graphs, legacy dialogues and scatter plot. You can put up simple scatter and you can just drop it, the current salary and the beginning salary, click OK and you will get the graph. Now, if I want to segregate this graph according to the male and female, I can set the markers also. Okay, let us go back. So when it is non-metric to non-metric clustered bar chart, metric to metric scatter plot. But what happens if it is non-metric to metric? What to do in such scenario? Let us try. Can we do it or not? Because here things will be that I'll be taking the mean of the continuous variable, because one is in non-metric. So I'll go in graphs, legacy dialogues, and bar chart. Simple, defined. And here I will transfer category axis as employment category, and here I will transfer as current salary. What is my current salary? Change statistics, it is mean, click OK. See this? What it is telling me that it is a mean current salary. See this? It is not a frequency now, it is a mean current salary graph which is being generated. The mean of clerical, mean of custodial, and mean of managerial. Now here, can we say that there is a significant difference in the salary or not? So here comes a point that we do the testing of the hypothesis. Suppose the CEO of this company has declared that on an average we are giving 40,000 to our employees. Okay, the parametric test. If we are giving 40,000, we assume that the data is normally distributed. So the claim is that the CEO is saying that on an average we are giving 40,000 to our employees. So we have to test the sample mean with the population mean. So where I will go analyze, compare means, one sample t test. And here I will check about the current salary here, and I will drop 40,000. Click OK. And you got the result. The claim was that on an average we are giving 40,000 to our employees. The claim got rejected as the p-value is less than 0.05. We reject null, and we'll say that the claim is false. Why? Because the mean salary is 34,000, 6,000 less than what was the claim. And there was a wrong claim which was coming from the company. Right? So here you have to see this p-value only. And your interpretation comes from p-value where you are comparing the sample mean with the population mean. There can be a scenario in which you are comparing the mean of two groups. So what to do in that case? Let us go there and see. So in case if your variable is non-metric to non-metric, both the variables are categorical, you can plot the and the statistics which can be computed is a frequency count and the chi-square. Let us see where we can do such things. I'll go here and I'll click on analyze descriptive statistics, cross steps, gender and minority, no, gender and I will include education level here. Sorry. And I will include the job category. So my question is there any association between employment category and the education level or not? Or my thinking is that with the education, my job category increases. As both are categorical variable, we'll be running the chi-square. But there are some ticks which you have to remember. This is non-parametric test, chi-square. So some ticks are that in statistics, make sure chi-square is on. Continue. Make sure that in cells you click on expected and row and column. Please click on this and expect it. Continue. Click OK. Your knowledge, there is no significant association between employment category and the education level, right? And you can see what is the chart giving it to you. See the red bar. So if you are studied till 12th standard, there is a very less possibility that you will go up to the manager. Okay, and if you have studied well, see like the purple color. If you have studied well, then you can go up to the managerial level. You don't have to even start from clerical. You will directly go to the managerial level. Right. So my statistics is this. And what I'll say, as the p-value is less than 0.05, we reject null hypothesis, which means that there is a significant association between how much you study and what is your level in any organization. So here, both the variables are in non-metric and non-metric. So we went for frequency cross tabulation and chi-square. There can be a possibility where both of your variables are running in metric to metric. For example, I want to study that what is the relation between my current salary and the present salary, the salary when I started my job. My null will be, now the words are kept reserved for each and every cell. When I'm working here in this compartment, make sure that I'm using the word there is no significant association between two categorical variables. Okay. When both of them are in metric to metric, I'll use the word there is no significant relation, there is no significant impact of X on Y. Right, this cell. Now here, one is metric and another is non-metric. Can anybody give me the example if you are listening properly? What can be the example to this? One is non-metric and other two are metric. Okay. Now you tell me that in case clustered bar chart is there, scatter plot is there, bar chart mean is there. Now here, see, this is, there is no correlation between two variables, right? And from where we will go? We'll go from here, analyze. My null hypothesis will be there is no relationship between X and Y. I'll run from here, I'll go here in current salary, done, beginning salary, done, done, okay. And what I get is this statistics, which will tell me that as the p-value is less than 0.05, there is a significant relationship between this two, and 0.880 tells me about the correlation. The words which I have to use here is there is no significant relationship between X and Y, and here I am using the word there is no significant association between X and Y. Okay, now comes the category which is this one, right? Which there is a claim that on an average we are paying 40,000 to our employees, and I want to test this claim. So I'll go from analyze, I will go in descriptive statistics, compare means one sample t-test, and I will just test it and click OK, and I'll get the result. So here the p-value is less than 0.05, so you reject null, which means that there is a significant difference in sample mean and population mean. Now you see the sample mean, it is just 34,000 and the CEO of the company had claimed on higher side. Now if I change this number to 34,000, what will happen? Just see all of you. See the p-value now. The claim of the company is that on an average we are paying 34,000 and therefore the claim is valid. Why? Because there is no significant difference between sample mean and population mean. One. Now comes the second part. I want to compare I want to compare the salary between male and female, and are they getting equal or not. Now here I cannot go according to the mean. I will have to do the formal testing, and therefore my null hypothesis will be, all of you pay attention here, we are in the zone of non-metric, metric, we are here. The test applied will be t-test and the words which will be used are here. There is no significant difference in my color and salary according to the gender. It means that male and female are getting equal salary. So from here, I'll go here and analyze, compare means, and I'll take the thing as independent sample t-test. I'll transfer current salary here and now I will have to define the groups. So one for male, other for female. Continue. Okay. So you got the result. Now here we don't have to see this values, we have to see this values. And here the p-value is less than 0.05. So we reject null. It means that male and female are getting some income disparity. There is a differences in the income. So here males are getting more salary in comparison to female. You can see this thing from here. See the mean. Now you want to compare that, is there any significant difference in after joining this company or not. So there is a concept of before and after. So from where you will go? You will go in analyze, you will go in compare means and paired sample t-test, transfer, beginning current salary here, beginning salary here, click OK. Now tell me what is your conclusion. Yeah, tell me what is your conclusion. Okay, the conclusion is that as the p-value is less than 0.05, there is a significant difference between current salary and the beginning salary. Yeah, there is a significant difference which we can see. And the difference is how much? On an average current, the difference between on an average current salary minus beginning salary is $17,000. See in the first column. Right. Now, in case if you don't get the normality which we were talking about and we want to run it on the, we want to run it here. See this. We want to run the test on nominal and ordinal. So in such scenario, what we can do, we can use a non-parametric test. From where to go? Analyze non-parametric test, legacy dialogues, and we can start with one sample or two independent samples. Here, the same thing which we had done of comparing the current salary, I will include now instead of gender, male and female, I will include minority. And I got the result. So if a person is present in minority and not present in minority, and what is a p-value? Here p-value is less than 0.05 and therefore we reject null, which means that there is a significant difference if a person is present in minority or not present in minority. This data is US 1994 survey which was done. It is a US 1994. It is a SPSS data set which is given default in all SPSS. So what is minority for them? I don't know. Right? It is a US data set. So as the difference is significant, we can say as the difference is significant, we can say that presence in minority can increase or decrease the salary. See, right? What else I can do? I can again go in and analyze non-parametric test. You can see dialogues, not key independent samples. Two related samples, just like your PAT sample T test. So transfer your current salary here, transfer your beginning salary here, click OK, and you will get the result. Please check it, all of you. So here, as the p-value is less than 0.05, we can see that there is a significant difference in current salary and the beginning salary. Now, how we can confirm this thing that my current salary is less than the beginning salary? It's not possible. You can see the positive ranks which are there. Okay, what is the positive rank? See this positive ranks. It means that always, irrespective of whatever you do, your current salary is going to have a higher. Your current salary is higher than the beginning salary, and as it is higher, your difference is coming out to be zero. Why? Because here beginning salary has been kept first. So beginning salary minus current salary, the difference positive is zero. And negative is 474 means naturally every person salary is going to increase. So beginning will be low and current will be high, and therefore you are getting all differences negative. Now in case suppose you are comparing more than two groups. So here t-test will not work. Okay. Before that, those who are not aware about this, that there is some concept of legacy dialogues. Sorry, independent sample here. Now see, when I go from here, I select run, and I'm specifying that please compare my current salary according to the gender. Okay. And when I say run, the thing is it will directly give me the output. It will also frame the null hypothesis. It will also give me the test. It will also give me the SIG value, and you are rejecting the null. Directly, everything will be given to you. Right. Now, if we are comparing more than two groups, then it is not possible to do that thing in the t-test, and for that purpose, we go in ANOVA. So, analyze, compare means one way ANOVA. I transfer current salary here, and the employment category was having three levels. So I go in contrast, nothing to do, post hoc Tuckies B, continue, options, means plot, click OK. Click OK. So here you get this thing. Okay, your p-value is less than 0.05, which means that there is a significant difference between the groups. But which groups are significantly different? For that we will have to do the Tuckies test, right? We will have to do the Tuckies test, right? How it can be done? I'll go back and I'll click here, and the thing which I forgot was post hoc. Tucky is on. Click on Tucky, continue. Okay. See here. Here, clerical is compared with custodial. The difference is $3,100, but the difference is not so significant because the p-value is more than 0.05. So all those pairs whose p-value is less than 0.05, right, whose p-value is less than 0.05, the significant difference exists between them. So clerical compared with manager, custodial compared, if you compare custodial with clerical, the difference is the p-value is more than 0.05, and therefore significant difference does not exist. But still, if you are having a confusion, the means plot will solve all your problem. Clerical compared with custodial, so the difference of the mean is not so big as clerical compared with managerial and custodial compared with managerial. Now, if you don't get the data normally distributed, what you will do? What do? You go in analyze, non-parametric, legacy dialogues, and here you pick up k independent samples. And now you take here current salary and employment category is taken here, different variables 1, 2, 3. And this is Kruskal-Wallis, the non-parametric version of ANOVA. So we have solved this matrix also. This matrix also solved, chi-square also solved, this also solved, this also solved. One thing which is left out is that is there any effect of the variables, independent variables on dependent variable? So I want to find out that my current salary, which I am drawing right now, is affected by what? Is it affected by my beginning salary? Is it affected by my job category? Is it affected by gender, previous experience, minority? What is affecting me? So I'll go here, analyze, and I'll say, okay, make a model which will tell me that my current salary is affected by what. So I go in current salary. Okay, I transfer education level, I transfer the beginning salary, how many months since hired, previous experience, right? And the minority person is present in minority or not. Just I'll click on OK and see what I get. So this is basically, it is related to the regression. So here the null hypothesis is that the model does not exist. It means that in the world there you cannot create any model. I already explained that we start with the null premises. There is no relationship between, or there is no association between. And here the p-value is less than 0.05, which means that the model exists, right? Now here you see the coefficients, p-value of the coefficients. If the p-value of the coefficients is less than 0.05, these variables are significantly contributing in determining your current salary. So you can see education level is contributing because its p-value is less than 0.05, beginning salary contributing, months since are contributing, previous experience contributing, but minority classification not contributing because its p-value is more than 0.05. The explanatory power of the model is 81%, which is considered to be the good one. The only bad thing about the model is there is one variable which is not contributing, and what we'll have to do, we will have to drop the variable, click OK, and now check the model again. So here click, things are okay. Here p-value less than 0.05, good, things are okay. Here all the variables are having p-value less than 0.05. Things are quite reasonable. So this is a way you create the model. Now you can have multiple options that you can also study. There is a concept of chart builder, right? You are not aware about any variable. So what you can do, you can just go here and click it, and you want the charts to be there. So you say that, okay, here I will drop education level, done, right? So it will be according to the count. And here you want also want the minority classification, right? I also want the minority classification. So I'll drop minority classification here. Just a minute. Okay. And minority classification, I will keep it here. Click OK, and you can see the result. See what it is doing for you. So this is just a drag and drop thing, which you can utilize for your sake to make the thing simple. Again, I'll go back. You don't if you don't want to run the command, you can do it very nicely. Go in chart builder, click OK, and from here you pick up scatter chart. Where as soon as you click on scatter, it will tell me that please tell me the two continuous variables. So I'll say current salary here. Okay, beginning salary here. Done. Right. Is there any filter which I want to install? So I'll say yes, I want to see the graphs according to my presence in minority. Filter on, click OK, and you see these filters are on. Right. So when I double click on this, a window will appear. Again, if I double click on this, a window will appear. And here, from here, I can do the necessary changes which are required. Right? The changes which I want, I can do from here. So thank you, Jugal sir, for always inviting me, giving me the opportunity on your platform. 2 minutes are left. Any question answers are there. Feel free to ask about this data science. It is a very vast science. Many softwares are there to learn, and it is like an ocean. You keep diving in it number of times. Every time it will come new and new things. So thank you, Jugal sir.
Thank you so much, sir. And we are actually very thankful to you because you accepted the invitation in a very short period of time, and your sessions are always, welcome for any these type of FDP programs, sir.
Okay, thank you, thank you, thank you,
So much.
thank you.
So, dear participants, now after 5 minutes, we'll start. The two things are left. One is feedback, which you need to give to all the experts by logging into your portal. And second thing is we will be conducting an exam. So, exam link I'll be sharing you after just 5 minutes. First, we'll conduct the exam, which you can take for like 30 to 35 minutes, and then I will close the link. After that, you just have to feed the feedback, and we'll finish it off. Okay, so we'll start the exam after just 5 to 10 minutes. I will intimate you before starting it. Thank you. Okay, we'll start the exam now. So I will share you the link, which is there on your chat box. I'll be sharing on WhatsApp also. So those who wants to give exam in what you can access from there also. There are 15 questions, multiple choice questions from the sessions which has been conducted. So you can take time of like 30 minutes, 30 to 45 minutes, and then I will close the link. So please go through the questions and answer it as soon as possible. Thank you so much. If you have any
Uh,
doubt, please.
Sorry to disturb you, sir. Can you please share the link again?
I have shared on the chat box also. So can you see the chat? Can you see the link? If not, then I can send you again.
Sir, please share it again. Na?
Yeah.